Evidences of seafloor spreading. We have more. There is a more. It has a tectonic activity and volcanic activity. There is an axial rift valley there. Age of ocean crust, near the M it is younger, and away from M it's older. Trench, there is a trench at descending limbs. There are enormous forces, crushed rocks and broken features at trench, and trenches seismic activity and volcanic activity. Also paleomagnetic evidences. So this is ocean floor A and this is ocean floor B. This is getting dragged down. Therefore, sediments of ocean A, they are scrapped and plastered against the edge of the ocean floor B. Therefore, there will be enormous compressive forces, crushed rocks and broken features here. Coming to plate tectonics theory, it wants to explain how dynamism of earth crust and mantle and interiors influence the features on the surface, like earthquake, volcano and fold mountains. And plate tectonic theory versus continental drift theory, it revived the possibility of continents moving, but the interpretation is completely different. It was inspired by two things: convectional current hypothesis, seafloor spreading. This was given by Arthur Burns, this was given by Harry Hess in 1929 and 1962. Now, plate tectonic theory assumes few things about that structure, which are lithosphere is 100 kilometers deep and it has a continental crust or ocean crust or continental crust, oceanic crust, and upper part of upper mantle. Therefore, this discards CL floating over Sirma, which was taken by CDT. This was given by the French geologist Le Pichon. And lithosphere is hard, brittle, and cold. Also, it is broken into segments called plates. The term plates was first used by Tujo Wilson, but similar concept was first given by Parker and Mackenzie in their paving stone hypothesis, which was first form of the plate tectonic theory. They called plates as paving stones. Lithospheric plates, they float over the semi-molten asthenosphere due to olivine, and therefore it can deform and flow under stress. The lithospheric plates, they may be entirely oceanic or entirely continental or have both of them. The plates are dynamic, so they move according to the influence of the convection currents. So because of this, the plates interact. So there can be only three types of interactions. They may collide, they may move over, they may slip past, which can be seen here. Coming to the major plates of the world, we have Eurasian plate, American plate, African plate, Indo-Australian, Antarctic and Pacific plates. The minor plates are Philippines plate, Arabic plate, Scotia plate, Nazca plate, Cocos plate, Caribbean and Juan de Fuca plates. Now plate boundaries and their associated interactions and features. So three types of plate interactions are possible. Therefore, three types of plate boundaries are there, which are divergent, convergent and transverse or transform boundaries. These will be constructive because they will move away, therefore new material will be forming here. These will be destructive because they come here and the fold mountains will form here. And these are transform boundaries are conservative because they just slide past each other. So these plates move away, they collide into each other, they slip past each other. So these are locations of new continental crust formation. Here ocean and continents get destroyed. Coming to divergent boundaries, they develop at which locations where there are rising and diverging convection current limbs. So this is the location. We have the rising limb, we have the diverging limb. Here the lithosphere snaps and the blocks move apart and a new material is formed here. So these may occur either under continental lithosphere or oceanic lithosphere. So there is a particular sequence how divergent plate boundary grows and develops. This is a logical sequence. Initiation under the continent, it will start on the continent, it can also start under ocean, but the logical sequence will be this one. And it will initiate at the hotspot, which is at localized deep volcanic source. From there mantle plumes will come, which are the hot rising magma. We can see here, this is the hotspot, and from here mantle plumes are coming. These mantle plumes will then push up the continent. Therefore domal upliftment, which is this dome shape, which will occur on the continent. So this domal upliftment example is Ethiopian highlands in the Africa. And later these DUs, they will develop the cracks. So these cracks will have forced volcanic eruptions, but they will be few and very localized. So these ruptures on DU, domal upliftments, they turn into triple junctions with three arms. So these are the triple junctions on the domal upliftment. So the ruptures, they develop into triple junctions. Later the vulcanism from the mantle increases and the triple junction grows. But when they are growing, so these are the different triple junctions. When they are growing, only two arms will sustain and one arm will fail. So these two arms sustain, these two arms sustain, these two arms sustain. So this one failed, this one failed, and this one failed. The failed arm is called alcogen. So we cannot anticipate which arm will fail. Later these enlarging arms, they will connect. So all these will connect and they will form a so they will join the numerous triple junctions, and finally a long rift valley will form. So this is a long rift valley that is formed. So this is a side view, initial domal upliftment. rupture and triple junction will form, later Rift Valley. After that, the continental lithosphere will completely break. So the felsic continental material is there. It will completely break, and new basaltic and mafic ocean floor will be formed, and nascent ocean will be formed. So the next step is to formation of the young narrow ocean, which is nascent. This is here with basaltic floors. This is seen, and later after that, proper ocean formation will form with more formation, which is mid oceanic ridge and a complete continental separation. Continents are completely separated, and this is a proper ocean. So this stage is what is explained by as a seafloor spreading by Harry Hess. Therefore, seafloor spreading is a special case of divergent boundary case. Divergent boundary can also explain how ancient supercontinent broke, and this explains the jigsaw fit of South America and Africa, how Atlantic formed, and how Africa and South America get separated. So this is a jigsaw fit. This is the Atlantic that has formed. Initially, they were together, and the jigsaw fit. Also, this is the African Rift Valley,